तो इस क्वेश्चन में एक यूनिफॉर्मली चार्ज प्लेट है दैट इज हैविंग साइड A and charge Q. From the center of the plate at distance A by 2, a point charge Q is small q is kept. So we have to find out the force on the plate due to this point charge. So for that, let's take a small area somewhere here. If you take small area here and try to find out the force due to this point charge, it will be somewhere here, df. You can see it will have two component. One will be, if you take this as theta, and this also will be theta. So d, this two component, one will be parallel and one will be perpendicular. At the same time, if at a symmetrical distance from this center, you take one small patch here, again here also this force will be in this direction, and it will have two components, one component somewhere here, another component down. So this will be df sine theta, and this will be df sine theta, this force, and this will be df cos theta. You can say this component will be cancelled. So we have taken this pair of patches. You take other patch also, there will be again a pair, and this parallel component to this plate will always be cancelled out. Only this perpendicular component will be left. So net force will be in downward direction here. So this will be df cos theta, which will get added. So net force, if you want, nothing but this, if you df, you can write integration of df will be that is net force, and this net force can be written as electric field into area, the small area. Electric field into area will be sigma electric field. This force will be electric field into area will give you flux. But this, how this df will come, force will be, we want q, we know this is q into a, so here you can write df is equal to this dq into e. Net force will be integration of df cos theta, you can write, because other component is getting cancelled. And if you further solve this df you can write as dq into e cos theta, and this dq we can write as sigma into a, sigma into dA here. Since the area is small, so we will write dA cos theta. Sigma is a constant, so it will come out of this integration, and you will write e dA cos theta, and which is nothing but a flux. So the final formula comes out to be force is equal to sigma into flux, and here the sigma is q upon, this sigma of this plate is capital Q upon area, which is equal to a square, and flux, since the distance here is a and this is a by 2, we can enclose this question can be solved using enclosing this hole through cube. It will be under the cube at the center of this cube, and the figure, if you enclose it, will come out to be like this, somewhere here. So from one face we know it is flux will be q upon 6 epsilon naught. So here we will getting the answer q, capital Q, small q, 6a square epsilon naught. This is the answer of the question.